class, this is Rook here, and today we are going to look at the topic of line of best fit. First, what I'd like to do is review a bit from yesterday, because yesterday we talked about interpreting the slope and y-intercept in real-world terms, and today's concept is really going to be an extension or continuation of that, so it would be good if we had a strong foothold in what we did yesterday. So, let's imagine that we're given a function. This function is on the screen and it shows the cost of an ice cream sundae with different numbers of toppings. And so that function is f of t, t is the toppings, is equal to 2.25 or 2 and 25 hundredths plus 0.75 times t. What is the y-intercept and what would it mean? So let's think about this. This function is discussing the cost of ice cream sundaes with a different number of toppings. So the output is the cost of an ice cream sundae. That cost is what your y is measuring, right? So the y-intercept, that's going to be what? What is the y-intercept? The y-intercept is when t, which is our x here, when t equals 0. Well, what does t mean? T is toppings, right? So t is 0. You have no toppings. What's going to be the cost of your sundae when you have no toppings? It is 225, right? Right here. 225 is our y-intercept. So let's put that in real world terms in the context of this problem. Our y-intercept is the cost of a sundae with no toppings. So it's 225, and it's the cost of a sundae with no toppings. So that would be how you would interpret it or define it in terms of the problem that we're looking at. Okay, how about the slope? Trying to get everything in the correct colors here. So the slope we know is in front of our input variable, which is t for toppings, and it's 0.75. What do we think 0.75 means here? We know it's the rate of change of t. T is toppings. So if you're thinking about rate of change of the toppings, that's the cost per topping, right? So it's a 75-cent charge per topping. So the slope is 75 cents, and that's the cost per topping. See, we make slope and y-intercept so much more relatable when we describe them through these word problems. This is one time I think word problems are fantastic because you finally have some real labels to put with these what can seem more abstract concepts. No, they're very real, very concrete, and we see that here. If Kai paid $6 for a sundae, how many toppings were on Kai's sundae? So if she's paying $6, that's her output. So that is f of t, which we know is the same as saying y. So we want to put $6 over there. So we know that $6 is the output, and that would equal 2.25 plus 0.75 t. Oops. So what do we need to do here? We have an equation that we then need to solve. So we need to subtract the 2.25 from 6. So I'm just going to type that in here, 6 minus 2.25, because I'm bringing it to the other side, and that should equal the 0.75 t. So what is 6 minus 2.25? Probably do that in your head pretty easily. That's going to be 3.75. And then we have that equals 0.75 t, and we need to divide off. So what is 3.75 divided by 0.75? How many times does it go in? It goes in exactly 5 times. So that means that Kai was able to get 5 toppings for that price of $6, which isn't terrible. Okay, so that's a review from what we did yesterday in terms of interpreting slope and y-intercept. Here's the thing. Sometimes data, when you graph it, it doesn't form a straight line. We call these graphs, or the graph data, when it's not fitting a straight line, we call it a scatter plot because it's scattered all over. But that doesn't mean that there's no relationship there. I want you to look at the three graphs that are on this screen. You're going to notice a couple things. In that very first one, the data, it appears to be traveling upward in a positive way with a positive slope. It's not perfect, but it does show a certain trend. And that's what we call a positive correlation. The data in the middle that are in yellow, that's really scattered all over. And that doesn't really show any trend. So we say that that has no correlation. The data in red at the end, we see that that data, as you're looking from left to right, as X is getting bigger, we see that the Y values are descending. That's what we call a negative correlation. Now, why is this important? Because if you have a positive or a negative correlation, you could estimate what an outcome might be if you could come up with an estimated line to describe this data. That estimated line is what we call the line of best fit. Let's look at another example just to get a better idea. Let's say that the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 12 days. So they graphed the data, and over the course of that 12 days, they looked at the temperature in Celsius in their sales. Now, we would definitely say this has a pretty strong positive correlation because as temperature increases, sales are going up. If we could construct a line through this data, we could estimate what sales would be for any given temperature. For instance, at 21 degrees Celsius, we might say, hey, it's probably going to be about 450. Because why? I am in my mind visualizing putting a straight line through this. That line that I'm visualizing putting through is what is called a trend line or a line of best fit. And you try to put it as close as possible to all the points and have an equal number of points above and an equal number of points below. Everybody's line is going to be slightly different because this is an estimation, but you do your best to make it as accurate as possible. So go ahead, if you've printed out this PowerPoint, and try and draw a line through that and see what you get. Now that you've tried to draw one, I'm going to show you what I've drawn here. So what I tried to do was fit it in the middle of the data and have about an equal amount above and an equal amount below. And remember when I said, hey, at 21 degrees, it's probably going to be about 450. My line is slightly above that, maybe closer to 475, but yours might be a little bit below. You accept a range of data whenever you are using a line of best fit to estimate. But these help companies, businesses, people make good, solid decisions about what future cost or profit might be based on their previous sales. And it's important that companies do this because a lot of times data is not going to fit a perfect line, but it might be close. And so this helps companies, businesses, people make decisions for the future that's based on the data. And it's not exact, but it's going to be pretty darn close. So it helps businesses prepare. Okay, so the next thing I want to talk about is actually coming up with an equation for that line of best fit. So we looked at how to draw them, but once you draw them, how do you come up with an equation? Well, let's use a scatter plot as an example. So look at the one to the left here. The orange data is the actual data. I have drawn a line through that pretty much has most of half the data above and then half the data below it. What you want to do is make sure that you extend your line to determine the y-intercept because whenever you're writing a line, the equation of a line, you need two key pieces of data, y-intercept and your slope. So I need to extend it, and I highlighted that point in blue. My y-intercept looks like it's at about 0.6. The next step that I need is to identify another point on that line. And there's so many different points. I try to pick one that's a perfect whole number. So I identified one down here that was intersecting at 9.4. Once you have 2 points, you can then find your slope. So to find my slope, I subtract my two y's. I get 4 minus 6 on the top, and I subtract my two x's on the bottom, 9 minus 0. My slope is a negative 2/9. Now that I have slope and y-intercept, I can formulate an equation, y equals negative 2/9 x plus 6, so that I could predict what would be a possible outcome for any x on that line. So if I plugged in 10, for instance, I'd have negative 20 over 9 plus 6. So I could get a potential answer for that. And I'm going to calculate that right now. That would give me about a 3.77 when I calculate it. And that sure does look like it. Might the data fall above or below? In actuality, yes, but this would give me a rough estimate. Okay, let's try one more. What is the equation of the trend line in the scatter plot? So the real data is the data in blue. I have gone ahead and drawn a line that I estimated through the data. It looks like about half of the blue dots are below and about half are above. So I drew a pretty decent line. Yours might be slightly different. I need to identify the y-intercept. That y-intercept crosses the y-axis at 0, 2. So I'm going to type that in, 0, 2. I'm going to change the color to blue just to set it apart. And you could be taking these notes on your handouts right now. I need to identify another point. And again, I try to find one that intersects perfectly. I identified 6, 6, but there's several others. Look, 3, 4. This one up here, 9, 8. Those just make it easy because they're not decimal values at all. But you can identify decimal values. There's nothing wrong with that. So 6, 6 is going to be my other sample point. Remember, we need those 2 points to find what? Step 3, to find our slope, right? So we go ahead and we're going to subtract our two y's. So we have 6 minus 2 on the top of that fraction. And then on the bottom, we have 6 minus 0. And so we end up getting a 4 on the top and a 6 on the bottom, which ends up reducing to 2 over 3. So that is our slope. So what would our equation in slope-intercept form be? I'm going to highlight this first just to set our work apart. So we would have y equals 2/3 x plus 2. And that would be the equation for our line in slope-intercept form. So if I asked you to estimate what the y value would be when x is 8, all you would have to do is plug 8 in. So you would have 2/3 times 8, and then that would give you a 5 1/3, and you would add 2 to that, and that would give you about a 7 1/3. Boy, oh boy, that is exactly what that line would estimate. Of course, again, it is an estimate, it's not exact, but a trend line helps companies, businesses, and other entities that have data that shows a positive or negative correlation, but it's an exact plan for the future.